Good afternoon. Shout out kay Andre na pumasok ngayon and sana may papasok pang iba, no? Pero let's begin and for today's lesson actually it's a two-parter, no? So isa-separate ko yung session natin. Delta entropy is fairly similar to how we calculate no, delta H. So medyo mabilis lang tayo doon. Pero I would like to take some time din para i-explain kung paano ginagamit ng Schumann stable, no? Because I have feedback that some of the students have a fairly difficult time to um, parang read the data that is contained in the Schumann stable. So two-parter tayo. First, explain ko muna yung Schumann stable, then we proceed with some relevant examples for entropy. Okay? So let's begin with ito muna. And I apologize na medyo mabagal ako gumalaw ngayon kasi medyo mahirap kasi mag-operate nung PC using one hand lang. Okay? So let's start with muna itong Schumann stable. So we take note that one of the key differences with Schumann stable versus yung nasa slides natin or nasa modules natin is that ang ginagamit na form ni Schumann stable is ito, no? Ito yung form na ginagamit niya for CP and Sorry lang. So, ang ginagamit kasi ni Schumann stable is this form, which is, if you observe, magkaiba siya dun sa, sa nakalagay sa modules natin. Because in our modules, specifically, ang pinakaiba niya is itong term na to, itong 2B. Okay? So, hindi ko na kung maglalag ulit ako. Let me Saglit lang, Andrea. Ito na. Okay. So, ito yung pinaka-glaring difference ng itong 2B because in our slides, naka-B lang siya. So, whenever we calculate whenever we operate with data that comes from Schumann table, we take into account na dapat ito yung form na. So, dapat naka-2B siya. Another difference is itong minus C siya. So, doon sa Excel natin is doon sa sheets, sa modules natin, I should say, is naka-plus lang ito. Okay? So, this is because ang ginawa kasi sa Schumann's table, no, is nag-start siya with this one. Okay? So, that's the big difference. No? We started with itong delta H. So, this is actually delta H, no? Kasi this is HT minus H298 means that this is delta H. This is the standard delta H of the reaction because ang reference natin is 298. Okay? So delta H niya is equal to itong AT plus BT squared plus CT minus 1 plus D. So kung i-differentiate mo, it will give you this form right here. Okay? So whereas in some other tables or some textbooks, they start with itong form of CCP tapos i-integrate nila. So kaya naka A plus BT yung ibang form. A plus BT plus CP minus 2. Okay? So let's take note of that difference. Okay? So that's the first difference. Tapos we also look at that fixes. Okay. So, ito din, isa sa titingnan din natin is itong form. So, you have two equations here, B times 10 to the 3, tsaka C times 10 to the negative. So what this means is, yung B times 10 to the 3 is equal to whatever value is nakalagay dito. Okay? So that is saying na, for example, if I take aluminum, yung B ng aluminum is B is equal to 1 point, sorry, yung B times 10 to the 3 is equal to 1.48. Okay? So that says that B is equal to 1.48 times 10 to the negative 3. Okay? So dapat pagka in-input natin siya, it's B times 10 to the negative 3. And since ang form dito is mayroon pang 2, so multiply nyo pa siya by 2 pag in-input nyo sa CP equation. So let's write CP ng aluminum. No? So this becomes A is equal to just 4.94. Tapos B is equal to, diba, B times 10 to the 3 is equal to 1.48. Therefore, B is equal to 1.48 times 10 to the negative 3. Pero meron pang 2 because that's how Schumann has formatted his table. No? So that's 2 times 1.48 times 10 to the negative 3 times 10 to the negative 3 plus, sorry, minus sa kanya. No? It's minus CP. So minus, and let's look, yung C niya is walang value. So that becomes just C minus. Yung 0 lang yan. Okay? Pero, again, similar to what we did, no? Kung C times 10 to the negative 5 to, therefore, if you take, for example, itong C alpha, so C of alpha ion is equal to C times 10 to the negative 5 is equal to negative 0.43. Therefore, ang C niya should be equal to negative 0.43 times 10 to the 5. Tama? Kasi we transpose your 10 to the negative 5. Okay? So, ganyan natin siya input. Tapos, since negative to, when we input it dito, magiging positive siya. Kasi minus negative. Okay? So, hopefully, that clarifies a few things. No? So, that's CPN. And the thing is, si CP pala for Schumann table is already in cal per mole. So, naka-cal per mole siya per degree Celsius. That's cal per mole per degree Celsius. Or, pwede rin naka-BTU per mole, per pound mole Fahrenheit. So, that's they have the same, they are the same units. Okay? So, since most naman ng calculations natin is either naka-cal per mole or joules per mole per degree Celsius, then pwedeng input lang natin siya diretso. Okay? So, isa sa nalilito yung estudyante is actually meron table dito, no? Meron nakalagay HT minus H77. So, you can actually, di ba, usually kasi pag nag-compute tayo ng delta H, you compute it by taking the integral of CP dt. And if you integrate this CP right here, kung integrate mo siya, ganito. Ito na actually yung form niya. So if you want, you can also, instead of the computing for the integral of CP dt, pwede naman diretso yung form na to. Tapos input nyo na lang A, B, C, and T. Kasi given naman siya. So you can do that. Pero for me, I just use itong CP dt form. Tapos, tsaka i-evaluate ko lang siya. Tapos eventually, I should get this form right here. Pero that is an option for you guys. Okay? Now, pero definitely yung lalabas na dyan, na value is in cal per mole. Okay? Now, merong isa pang feature dito si Schumann wherein meron siyang actually tina-tabulate na ng mga common values. So meron siyang 200, 400, 600, 800. So sometimes, kunwari, yung tinanong sa problem is, what is the delta H of formation of the delta H of your sample or your metal at a particular temperature, let's say 400. 400, then actually, ito na siya, di ba? So this is the delta H na of formation ng aluminum at 400. Ito siya. Kasi itong HT minus 877, this is saying that this is the delta H Etong H77 na to, this is the room temperature at in terms of Fahrenheit. No? So when you say HT minus H77, you are saying na H at the elevated temperature T, which is whatever temperature na kinuha mo, minus delta H. So technically, delta H siya. Delta H, kasi di ba, pagka kumukuha tayo ng delta H, it's always a standard na value from a reference temperature, and then pili nating reference temperature is the room temperature, which is 298. Okay? So, pwede nyo siya i-compute, pero definitely, hindi siya good practice na umasa sa table na to. Kasi, for one, ang values nitong HT-77 na to is naka-BTU per pound mole. So, minsan, mahirap mag-convert. I don't advise na you use this table to in that math. Kumbaga, kung maghahanap kayo ng delta H formation at elevated temperatures using this table. Pero, what you can do is, actually, ito, no? So, if you notice, at the transformation temperatures, so for example, if you have aluminum, this is aluminum crystal, meaning solid to liquid. No? So, at 1217, notice na ito siya, 1217, it will notice how yung next temperature na is the same temperature lang, 1217. So this means that this is actually your transformation temperature. Okay? This is the transformation temperature. And for this particular case, this is the melting temperature of aluminum because this is from yung C dito signifies crystal, which is solid. Tapos yung L dito signifies liquid. Okay, so it transforms from the solid to the liquid phase, and this is the associated na delta H. Kasi again, ito is kumbaga delta H ng liquid. So if you think about it, ito kasi this value right here. Okay. This value right here. This is the delta H of your aluminum solid at 400 degrees Celsius. At 1217. Tama? Tapos ito, this is the delta H at 1217 of your aluminum liquid. So if you get the difference between the two of them, then you're actually just taking the delta H of transformation. And in particular, ito ay delta H, and we can write it this way, no? Aluminum solid to aluminum liquid. So that's saying that if you get the difference between the two of them, like such, balik rin natin kasi final minus initial kasi. So that's delta H ng aluminum liquid minus the delta H of aluminum solid is just equal to the delta H of transformation from solid to liquid. Tama? So, if ganun yung case, then if we deduct these two values right here, so from 12,330 minus 7,700, if you get the difference between the two of them, you will actually get the delta H of transformation. Pero again, it's in BTU per pound mole. Okay? So yung BTU per pound mole, convert nyo pa muna sa cal per mole or yung kilojoules per mole. Okay? Okay? So, yun lang siguro yung mga important features nito. Whenever you see this line, this just means na meron kang transformation occurring. So again, this is for copper. You look at copper, this is degrees Fahrenheit. So that's 983. That is your melting temperature or your transformation temperature from solid crystal to liquid. Okay, tapos ito yung associated. If you get the difference, ito yung delta H of transformations or the latent heat of transformation. Okay, so for the keen observer in the class, no, you probably have noticed this value, no? You notice na wala siyang difference actually. No? So notice how the transformation ng alpha to beta is 11:6:30 tas 11:6:30 lang yan. So if you've been following the podcast, no, you might have parang naalala nyo na na-mention ko na beta is an obsolete form of iron. So this is actually for iron. So ito yung mga different allotropes of iron. No? You have alpha, beta, gamma, and delta. So I mentioned na obsolete yung beta because actually si beta is just it has the same crystal structure as your as your as your alpha. Ang nagbago lang is yung magnetism niya. Okay? So actually parang walang masyadong nangyari sa material mo. That's why you don't have any uh, associated change, no? So that makes beta obsolete. And for if you for just a fun fact, no, itong tawag dito sa temperature na to, this is the Curie, I think Curie temp. This is the Curie temp. Okay? So it's just when your alpha changes to beta, which again, beta is an obsolete form. So that's why, again, wala siyang, if you take the delta H of transformation dito, that's 0. So wala siyang delta H of transformation. Okay? Now, if you get beta to gamma, ito na yung transformation. Okay? Delta H of transformation from beta to gamma. Pero we can also say, no, itong transformation na to can be said as the transformation of, kasi minsan, ang sulat lang natin parati is for iron is alpha to gamma. And this, you probably notice this sa mga material science ng lectures, you know. It's always from ferrite, this is your alpha, to gamma, which is austenite, to your delta ion. I forgot what the name of delta ion. May specific name din siya. It's just eludes me. Pero parang ganito, no, hindi na siya dumadaan sa beta kasi again, obsolete na si beta. So, ito, if you want to get the delta H of transformation from alpha to gamma, you just take this transformation from beta to gamma. Kasi technically, ito is the same structure. Ito pa rin si alpha, iba lang yung, kumbaga, magnetism. So if you get the difference, that's the delta H of transformation. And take note again, naka-BTU pounds, BTU per pound mole siya. So you still need to do conversions para maging kilojoule per mole siya or joule per mole of halton. Okay? So I think that's all you need to know about about how to use the Schumann's table, because kahit tapos na yung delta H, yung enthalpy lesson natin, no, the Schumann's table is still very much used kahit sa entropy tsaka delta G na discussion. So it's important that we know how to use this table right now. So before I proceed to entropy, meron bang specific other questions about this Schumann's table?
Sir, may tanong po ako.
Go, Mark.
So, sir, sir, di ba sabi niyo po obsolete siya yung latent heat of tawag nito, fusion or transformation. Pero sir, since pareho nga sila obsolete siya, yung value ng LM mo, pero mayroon po kasing iba po kasi yung values ng alpha to beta pagdating sa CP. So kung i-draw mo siya sa thermodynamic loop sa transformation niya from T1 to TF, pwede pa rin po ba nating i-supply pa rin sa equation yung function ng CP, values ng alpha to beta, kahit
pwede
zero
rin naman. Oo, okay lang yun.
Kasi, okay sir, no?
Oo, kasi
Kahit zero rin naman yung sa LM, pero meron kasing value ng CP.
pwede pa rin naman. Pwede pa rin naman. Okay lang.
Incorporate sa equation, sir, no? Okay lang.
Kung kunwari, pag pinagawa kayo ng loop, then obviously, pag pinagawa kayo ng loop, for example, isasama nyo si beta. Although in modern pagka mga equations na, usually hindi na sinasama talaga si beta kasi siya, parang obsolete na siya. Pero in any case, kung pinagawa kayo ng loop from, let's say, temperature of 298 or 7 Fahrenheit to let's say itong 2000 na Fahrenheit, no? Ito, 2,000 pa rin. Oops.
Mm.
2,000, isasama nyo pa rin yung beta na loop din. So, kumbaga meron pa kayong magiging FE, alpha to beta, tapos akyat, FE, beta to gamma, tapos akyat ulit, FE,
Tama.
gamma to delta. Okay? So, yun.
Pero yung alpha to sigma, sir, that is still ano, sir, no? Crystallized pa rin siya, sir, na
Alpha,
tama na.
sigma. Kasi
Alpha
lahat,
to sigma, that
itong
is
lahat na
still
to, puro
crystal.
crystal forms to ng iron. So, mga allotropes
Tama,
is like.
tama, tama.
Okay?
Okay, sige. Salamat, sir. Yun lang pa.
Okay. Other questions sa Schumann stable? Usually naman binibigyan na namin yung mga values pero there are cases wherein pinapahanap namin yung values through the Schumann stable. Okay, so and class no, pagka kunwari meron kayong nakuha value for BTU per pound mole based on Schumann stable. You can use you can use internet resources also. For example, you can just directly convert it. So meron kayong mahanap na sa internet, marami naman yung mga conversions. No? So you just input kung anong units, tas anong value, tas siya na mag-i-input. So that's perfectly acceptable. No? So ilagay nyo lang na kung ano yung nakuha yung BTU per pound mo, tapos i-convert nyo lang. So no need to show kung kunwari ano yung conversion factor na ginamit nyo. So hindi na necessary yun. Okay? So I think I've covered enough ground dito sa Schumann stable. So let's proceed with several examples of our workspace. So for today, in the rest of the session, kailangan natin discuss tayo about entropy. Okay? So again, I mentioned na si entropy, yung calculations na as in sobrang similar lang sa and if you've read your modules, you probably notice na parang halos same lang yung gagawin equations. No? And only difference is magkaiba lang yung niya, yung may over theta lang na nilalagay, which does not change much, no? Or it changes the values, yung magiging evaluation natin. Pero kumbaga yung step-by-step procedures natin actually, it's quite similar. No? The way we do the loops, it's still the same. No? Napuputol ba ako? Unstable ba internet ko? Hindi ko kasi sure. Double check ko. Nabalik na ba ako? Sorry. Medyo mabagal lang kasi yung internet dito sa office na.
Opo. Okay na po. Salamat, sir.
Okay, so sorry about that. Nag-change connection na ako. Hopefully, mas ano stable na yung connection ko. Okay? So, as I was saying, yung calculations ni entropy, very much the same. Yung steps na pinitake natin, it's very much the same as the calculations. So, okay, stop sharing. Very much the same as yung ginawa natin sa entropy. And nagpo-continue pa ba ang recording? Okay pa naman. Okay. So let's try, no? Open. So what we'll do here is before we start, I'll highlight a few of the or two of the formulas na sobrang magagamit natin. So in the handouts and even in the modules, there are several na variations of the delta S and how it can be written. Pero in our case, mostly yung gagamitin natin are only two forms. So the first form is yung tinatawag nating entropy change associated uh, with uh, with sensible heat. Okay, so when we say sensible heat, ang ibig natin sabihin nun is dito pa ba ako or nawala ako? Hello? Nawala ba ako?
Opo, sir. Kanina.
So, I apologize no kasi nasa office kasi ako ngayon. I had to come to work today kasi may experiment kami. Kaya medyo iba yung setup ko ngayon. Pero, ayan, saan ba ako naputol? Sa, nag-discuss ako about the two forms of delta S na gagamitin natin. Tama?
Opo.
Yes, sir.
Okay. Thank you for the feedback. So, ang two forms, sorry. Nakashare pa ba yung screen or nawala? Nakashare pa naman. Okay. So, meron tayong two forms na ginagamit. No? Yung first form natin is, yung first form na ginagamit natin is yung tinatawag natin na delta S that is associated with the um, the delta S associated with sensible heat. So when we say sensible heat, always ang iniisip natin dyan is CPDT. No? Okay? So that is heat caused by the parang raising of the temperature of a particular species to an elevated temperature or lowering of the temperature. So pwede siyang negative kung ilo-lower, positive siya pag ini-increase natin. Okay, so that's sensible heat. So that's delta S. And we know that yung form is delta S is always some form of, I don't know, dq over dt. Parang ganyan yung form kasi. So, to solve for delta S for yung associated with your sensible heat, equal lang to sa Cp dt, which is your Q over T. So, if you notice, yung over T natin is not outside, no? Nasa loob siya. Okay? So, later on, I'll show you one of another form wherein, I don't know, meron tayong delta S na ganito yung form, 1 over T times Cp dt. And I'll show you an example of this. No? So, kung ano yung difference ng dalawang to. Usually, pag sinabi natin ganito, this is for the system. No? So, whatever yung species na ina-analyze natin. Whereas, yung difference nito, yung delta S na to, wherein nasa labas C1 over T, this is what we call as the delta S for the surroundings. Kasi usually ang assumption dito is we have a parang chamber kunwari or pwedeng surroundings or in more or yung common example is reservoir. So pwedeng reservoir surrounding. Kasi usually ang example natin dito is meron tayong reservoir. So normally it's water, no? And it's a large reservoir and we maintain the temperature at a particular temperature, and because it's large enough, we can assume na hindi nagbabago yung temperature ng ano na to. So ng bath na to or reservoir na to. So if you have a system, kunwari nandito yung system mo, let's say for example a piece of metal, aluminum kunwari. So when it changes or kunwari nagre-react siya, nagre-change siya, nagta-transform siya to some other form, it releases or absorbs heat. So whatever is released or absorbed, Q, it is done at constant temperature. Okay, so that's why nasa labas yung T na to. For in terms of if you look at what the delta S of the reservoir or the delta S of the surroundings is actually experiencing. Whereas kung si aluminum, yung delta S na i-experience niya is incremental in nature. No? So meaning every change in temperature, yung infinitesimal change in temperature is has an associated na delta S value. So that's why nasa loob ng integral kasi infinitesimal yung change, nasa loob ng integral itong 1/t na to. Okay? Pero sige, that's ahead of ourselves. We're going ahead of ourselves na. So, hindi ko muna isusulat to. So, ito lang muna, focus muna tayo dito. So, this is the first form na importante sa atin. And the other form is yung delta S na associated with transformation. No? So, the delta S associated with transformation is this occurs when you have uh, any sort of transformation, whether this be a latent heat of fusion, pwede siyang latent heat of transformation, latent heat of vaporization, any type of transformation, as long as it occurs at a single temperature. So something like a melting temperature or a transformation temperature or a gasification temperature, any sort of plane transformation, then we can just calculate it as just the delta H of the transformation divided by at what temperature that transformation occurs. Okay, so that's the, I don't know, ito yung form. So ito yung, itong dalawa, these are the common delta S na kailangan natin i-solve. Okay, so let's try an example. No? Let's try an example. Ito muna. Let me know kung naputol ako, guys. Kasi hindi ko actually nakikita. Dito kasi sa office, once na malapit na mag alas 5, parang nagiging unstable yung internet. Try this. Okay. So meron tayong sample problem. So sabi daw, zinc melts at a temperature of zinc melts at a temperature of 420 degrees Celsius. System tayo. So zinc melts at a temperature of 420 degrees Celsius or that's 693 Kelvin, and its standard entropy at 25 degrees Celsius is 298 is 9.95 calories per mole Kelvin. Okay? Tapos we need to calculate the standard entropy of zinc at an elevated temperature of 1023 Kelvin. So we are given these following values. Transformation, and we have CP values now for zinc uh, zinc that is solid and zinc that is liquid. Okay? So to solve this, we just need to imagine kung ano yung mga delta S na dinaanan ng material. No? So it starts off as zinc. Hirap kasi i-control yung left hand ko kasi it's still in cast. No? After 2 weeks pa kasi siya fully healed. So after 2 weeks, medyo mas mabilis na ako gawa ng mga stuff. Okay? So we started off as zinc, no? That's in its solid form at 298. So this is indicate na 298 ang zinc, no? Or let's say we have T is equal to 298. Okay? So that's zinc solid. Tapos sabi natin, i-raise natin yung temperature ng zinc solid natin into zinc liquid. So i-raise, di ba, i-raise natin siya to zinc liquid, which is at the elevated temperature 1023. Okay? So, but before it undergoes, kumbaga, the elevated temperature, kailangan mo dumaan muna siya sa transformation. No? So we need to undergo zinc liquid transformation. And this occurs the um, at the transformation temperature, no? And the transformation temperature is, we can use Schumann's table, no? Hopefully dito si ano ko ba? Zinc's transformation temperature is 627 Kelvin. Dito naman, pwede natin gamitin pa. Okay? So that's 627, 692, I mean, 93 na lang, 693. So let's do T693 Kelvin. Binigay ba dito? 693. Okay. Sorry. Binigay pala ka. Dito naman pala, 693. Pero nakasulat din naman sa Schumann's table. Okay? So T is equal to 693. Okay? Now, once it transforms, it also has, it needs to go up to, sabi sa problem is 1023 Kelvin. And this is still zinc liquid, but now at a higher temperature. Okay? So we started with parang state 1 ito, state 1. Then we went to state 2. Tapos, umabot tayo sa state 3. Okay? So if we want to compute for the delta S of zinc liquid at 10.3 Kelvin, then we actually just need to add all of the delta S. Kasi technically, ito siya is delta S, this is delta S from state 1 to state 3. Tama? So, to calculate this, we just need to calculate delta S1 plus delta S2 plus delta S3. Okay? Or more accurately, this is delta S from 1 to 2, from 2 to 3, and, from 1 to 2, meron pa pala, no? This is supposed to be, ito pala yung state 2 natin. State 3 to, tama? Kasi nag-change siya ng state from when it transformed into liquid, and state 4. Okay, so this is supposed to be, ito dapat from state 1 to state 4. Tama? From state 1 to 2, 2 to 3, then lastly 3 to 4. Okay? So yun yung mga delta S na kailangan natin. Okay? So the first delta S natin is this one. Oh? This is the delta S. First delta S, and this is a, itong delta S na to is a sensible. This is brought about by this, associated with sensible na heat, no? Tama? Just by raising the temperature. Yung delta S dito is a latent type of sensible or associated with the latent heat. Tapos yung last na delta S dito is again similar dito sa first na delta S natin, which is associated with sensible heat. Okay? So knowing that, pwede natin siya isolve, no? So delta S from 1 to 2 is just equal to, this is equal to integral ng Cp from 298 to 693. Tama? Cp, which is, and let's input the Cp as well, no? Direction value. So Cp of zinc solid is this one. Input na natin. 5.35 plus 2.4 times 10 to the negative 3 times T. Okay? And we divide this all by T, no? Tama? And we raise this to okay? Enclose it in T, no? So that's the first delta S. Tapos, add natin si transformation naman. So, associated with transformation, latent heat. So we use the other form, no, which is just delta H of transformation divided by the transformation temperature. So let's input that. age of transformation. Dito nakalagay, the delta age of transformation or the latent heat of fusion is equal to 7 to 80 joules. So when we say fusion, it usually means um, from solid to liquid. That is the heat of fusion. Pero one way you can look at it is for most, and this is applicable for most metals. No? When you talk about melting, is just try to imagine, if it starts from a solid and it becomes a liquid, try to imagine kung anong type of heat ba yung kailangan para mabuo to. Okay? So just imagine this, no? This is, di ba, solids have lattice formation, no? So kung ganyan, this is your lattice. And hopefully you still remember your Fismet, no? Or Fismet na ba kayo? Or yung basic na physical metallurgy. So kung may lattice siya. So for you to be able to produce the liquid, and the liquid is just, I don't know, parang random na, wala na silang lattice formation. So random. So for you to be able to produce this, kailangan nyo i-break yung mga bonds na to. Okay? You need to break those bonds. Diba? And for you to break those bonds, kailangan mo mag-absorb ng energy, which means that you need to have a positive delta H. You need positive delta H para i-break yung bonds to produce a free-flowing parang arrangement, no, which results to the liquefaction of your metal. Okay? So, ganyan nyo lang isipin kung if you're unsure whether it's positive or negative, just try to imagine ano ba yung nangyayari. So, if the opposite is true naman, no? So, for example, from liquid to solid, imagine it, for you to be able to form these bonds, you need to absorb energy kasi kailangan mo ng energy to form the bonds. Okay? So, therefore, dapat yung delta H dito should be negative. Okay? So, just try to think of it that way. No? Pero again, ito, given is that, I don't know, ano yung gusto natin? This is in calories per mole. So, solve na lang natin siya in terms of, ano ba? Joules per mole na lang. Tama? Naka-calorie per mole, pero naka-joule per mole din yung set. Mas madali siguro kung calories per mole na lang i-solve natin. So let's do calories per mole. So let's take the calorie per mole value, which is this one. So that's in kilocal. So you do 1740 calories per mole, and we divide it by the transformation temperature. No? And what is the transformation temperature? It's 693. So you know, okay. Tapos yung last natin is yung sa liquid phase. No? So that's from state 3 to state 4. No? So if we input that, that becomes from 693 all the way up to yung final temperature natin of 1023. Okay, that's 1023. Okay, so what is the CP value? It's 7.5 cal per mole. Okay, so that's 7.5 divided by P dt. Okay, so let's try to solve this, and you can use MS Math or pwede din actually yung calculators nyo. You know, so let me just open. Meron actually yung calculator.
Sir, may tanong lang po ako, sir.
Sige, go ahead.
Bale, yung ano sir, di ba po, yung kasi parapansin ko po may letter T na i-divide pagdating sa DT. Bale, na-divide rin siya yung 693 sa latent heat of transformation or fusion. Bale, ang T niya na-divide sa HFI, yung T value ng temperature. So, bale yung T po ba dito sa state 1 to 2 at saka state 3 to 4, same as value ng temperature o value siya ng corresponding to the CP values na may T sa CP values? Literal ba siya letter T or temperature yung T na dinivide sa state 1 to 2 at saka state 3 to 4?
Kumbaga kailangan mo i-simplify siya, no? So for example, ito, so magiging 5.35 over t plus 2.4 times 10 to the negative 3. Tapos magka-cancel out na yung t. So,
So literal sa letter T.
mm,
Kasi yung dito kasi sa state 2 to 3, ang T natin diyan is 693 temperature. Kasi 'di ba dinivide mo
kas,
siya?
kasi again, nag-occur lang kasi siya at one temperature, no? So wala siyang, kumbaga hindi siya infinitesimal change. So kaya hindi mo siya
Oo.
ini-evaluate along the integral.
Okey, okey, gets, gets. Sige po.
Okay,
Cancel na sila.
sige. Ah,
Okay.
so, wait lang, kasi kailangan ko ilabas yun. And I feel like most of you owns this type of calculator. So let me open the calculator. Okay. So sabihin niyo kung nakikita yung calculator. Tama, nakikita ba? Actually, nakikita niyo doon nakikita niyo, no? Sa bottom right.
Yes, sir.
Opo.
Okay, that's good. So try natin, input tayo. So let's do, ano ba yun? 5.35. So para ano yun din, experience kung ano yung tsura pag calculators yung ginagamit natin. So that's, kasi pwede yung i-input lang siya diretso, no? Pero, so, 5.35 and this is divided by, we can use alpha x. So we say x yung CT dito. Okay, so that's plus, this is 2.4 times 10 to the negative 3. Then our limits of integration is 298 to 693. Nakikita yung calculator, no? So,
Yes, sir.
so we can evaluate this. Evaluate lang natin pa isa-isa. Hindi tayo man. So, ang first value natin is 5.46. Okay. Tapos next, ito straightforward lang naman itong pangalawa, no? Which is just, yung pangalawa is 1740 divided by 693. Okay. That's 580. That's 2.51. Okay, 2.51. Tama ba? Let me just make sure na tama yung value na po. What? Tapos, and this is all in calories per mole Kelvin. Tapos, next natin is, again, siguro balikan. So, this is at 7.5. Tapos, alpha x. And let's evaluate it at 693 up to 1023. So your calculators are actually quite powerful in time to solve itong mga integrals na to. So you get 2.92. Of course, you can also use MS Math, no? MS Math can still evaluate these types of problems, no? Eh, napuputol ba ako ulit?
Hindi naman po.
Hindi naman. Kanina pa pa itong conversation. Okay. So, okay pa tayo, no? So, if we evaluate everything, we should get delta S, and let's calculate everything. No? That's 5.46 plus 2.51 plus 2.92 gives us 10.89. 2.92. Para may lahat.
Sa akin po kasi sir is 5.446. Maliit lang naman eh.
5 point doon sa delta S1. Doon
Instead
sa
of 5.46 or something like that. Maliit lang naman, values lang kasi.
konti lang naman error. Sige. Pwede na siguro yun. Ay, alam ko na. Is it 5.35 or 5.53? 5.35. Okay, so I'm checking our handouts, no? And sa handouts pala natin, may mali doon. 5.53 yung nakalagay. Kaya siguro mali yung naging value. Pero anyway, the steps are correct. So, eto. So, ano yung nakuha mo, Mark? Sorry.
Hindi po. Since 5.33 na yung gamit ko eh. 5.53.
53 din gamit mo?
33.
33? Okay. Sige. Kaya siguro may minute na differences tayo. Pero anyway, if we use this one, so we should get 10.89 and that's calories per mole Kelvin. Okay? Tapos, we're given 1 mole, no? Tama? Ano ba sabi? 1 mole of, dun sa problem, if we look at the problem. Okay? We are given standard and, wala klaseng hindi. Okay. So, kung walang sinabi, na, per mole basis tayo. Ganun. So, that's 10.89 calories per mole of zinc Kelvin. Okay? So, that's how we complete the test. So, okay tayo dito so far, no? Wala namang question?
Di ba sir, pag hindi given yung number of moles, always assume na N is equals to 1. Tama di ba sir? Mole mo is always 1. Pag hindi
So,
given.
kumbaga parang sinasabi mo na on a per mole basis ka. So, pag ganun, all your calculations can be multiplied by 1 or pwede namang hindi mo actually multiply by 1 mole, no? Since you're assuming na naka-per mole ka.
Oo. Parang sabotable na siya na okay na. Ganun. Sir, bali sir, yung delta S natin dito sir, di ba sensible heat siya? Ito rin po yung nag-incorporate sa na symbol for standard entropy sir, no? Tama po ba ako?
This is standard. Kasi pag sinabing standard entropy, this is entropy na may reference ka at 298. So,
Tama po.
kumbaga kino-compute natin si delta S at 1023. Hindi talaga siya yung S at 293. So, if I were to write this down, no? We are not computing for S at 1023. We are actually computing for S at 1023 minus S at 298. Okay, so that which gives us the S at 1023 standard. So, minsan sinusulat siya, and this is depending on what textbooks you look at, minsan sinusulat siya as ganito. So, standard meaning ito, parang degree symbol nito. Okay? So, let's proceed with the next problem. No? Let's try itong mas mahirap na problem. Problem. Problem is, meron daw tayong meron daw 1 mole of low carbon steel in that is at 900 Kelvin, and it is quenched and held in contact with a large reservoir at 700 Kelvin. So we are to compute for the delta S of the steel, the delta S of the reservoir, and the delta S of the universe. So let's assume that the reservoir is sufficiently large to maintain that constant temperature. So this is an important assumption class. No? Now, when you see these types of problem, always may kasama siyang ganitong assumption. No? So ito. Assume that the reservoir is sufficiently large to maintain constant temperature. Because if it weren't large enough, so for example, if you have something like ganitong reservoir, no? Tapos pinasok mo yung steel dyan, dapat, if this were at 700 Kelvin, because you quench it with 900 Kelvin na steel, dapat ito, This will cool down, no? Si 900K will cool down. Pero si 7, so ito bababa yung steel temperature. Ito dapat tataas, no? And you can observe this for, ano, no? Kahit mag-ano kayo sa mga experiments nyo. Kunwari, if you're in the steel industry, tapos, and maybe you can experience this pag nag-face-to-face na, no? So there are experiments where we do quenching experiments sa laboratories natin. And you'll notice that when you quench your metal, in something like oil or water, immediately yung quenchant mo from room temperature, iinit siya, no? Tataas yung temperature na. It's because of the transfer of heat, no? But when you have a sufficiently large na reservoir, no? If it's sufficiently large, 700 Kelvin, and sobrang late ng pinasok mo na, ano, na material is 900 Kelvin, no? You can assume that, and you kahit pwede sigurong you can do certain experiments. Kunwari, meron kang mainit na, ano, mainit na cup of coffee. Pag naglagay ka ng particle of sugar siguro, kunwari, mga small particles of sugar, kumpara sa reservoir mo, which is the coffee, sobrang, this particles of sugar is at 298, no? So, basically, technically, it will lower the temperature of your coffee, tama? Because, kumbaga mag-absorb siya ng heat because it is at lower temperature. Pero what ends up happening is, itong pinasok mo, sobrang liit lang niya kumpara doon sa coffee mo that hindi actually magbabago yung temperature ng coffee mo. So that is exactly what happens when you have a large enough reservoir, no? So you can assume na throughout the quenching process, while you are quenching this, yung reservoir mo will always be active, will always maintain its whatever temperature it is maintained at. So in this case, 700 Kelvin siya. Okay? So that's what happens here. So first, compute muna natin si delta S ng steel, no? And in this case, we can say that the delta S of the steel is the delta S of the system. Is steel. So the delta S of the steel is equal to quenching reservoir. So, ibig sabihin, it will eventually meet the temperature of the reservoir. Kasi kumbaga, as you quench your steel, pababa ng pababa yung temperature niya. Tama? Kasi kumbaga, i-quench natin. So from 900, bumaba ba siya hanggang dun sa minamaintain na temperature, which is 700. So we are quenching this we are starting at 900 and we are quenching it up to the final temperature of 700, which is a lower value. So we expect na dapat kasi this is all sensible heat, no? Kasi sa temperature range na to, 900 and 700, if you look at Schumann's table, no? So just to be sure, let's look at Schumann's table. If you look at Schumann's table, in between, and this is all in Kelvin na itong transformation temperatures na to. Sa range pa tayo ng nasa alpha range pa tayo. No? So 900 is, so wala naman tayong tinatawid na transformation. So kung meron kang tinatawid na transformation, then you have to take into account that transformation. So kumbaga may additional step ka pa. Pero in this particular case, wala naman. Therefore, ang value natin is automatic sensible heat lang yung association natin. Okay? So 900 to 700, so we would expect na negative yung magiging result nito because we're lowering the temperature. Okay? So we do CP of our FP. And walang binigay, no? CP. So we have to find the CP value. So let's look for the CP value. CP dt over T. And this is for FE. Okay? So we write it this way. So let's find for the CP value of our FE. So again, nasa 900 down. CP values is this one. Diba? So that's 3.37 tapos 3.55 times 10 to the negative 3 tapos 0.43 times 10 to the 5. Diba? So again, for those who missed the discussion, kasi ang sinasabi dito is B times 10 to the 3 is equal to whatever value here. So therefore, if you want to find B, then you need to divide it by 10 to the 3, which gives you 10 to the negative 3. Tapos ganun din sa 10 to the 5, which is 10 to the negative 5. Divide mo by 10 to the negative 5 gives you C is equal to 10 to the 5. Okay? So let's input that. We have, oops. This becomes 900 to 700. And 3.37, 3.55. So that's 3.37. That's 8 plus, and again, so for those who missed the initial parts of this lesson, we always look at itong form na to. And si Schumann has this form. No? It's different from the form that is available in our modules. No? Sa modules natin, ganito yung form. A plus BT plus CT to the negative 2. Dito, A plus 2B T siya minus CT. So itong plus 2B and minus CT yung difference. So we need to take that into account. So dito, magiging 3.37 and also get 3.55. So that's 2. That's 2 times 3.55 times 10 to the negative 3. And this is T. So mamaya ko na ika-cancel out yung mga yung T values. Tapos plus yung, minus. No? Minus, pero negative siya. Look at it, negative 0.43 minus negative 0.43, which equals a positive value. Okay? So, again class, be mindful dito kasi posibleng dito magkakamali kayo. Always remember na ito yung ginagamit na form, this form. This is what Schumann uses. So you need to take that into consideration. So this becomes T to the 10 to the 5, raised to the power of T to the negative 2. No? T to the negative 2 dt. So we divide this all by E. So we should get, and diretso nyo, no? Ito basta magka-cancel to, set of T to the negative 3. So pwedeng labas yung calculator ko. Nakikita pa naman yung calculator ko, no? Kita pa naman. Kita pa. Thank you for the feedback. So let's input the values. No? So we have 3.37. Oh, sorry. Integral. Tapos 3.37 over x. Tapos plus 2 times 3.55 exponent negative 3 over t magka-cancel siya. So ito nga minus negative, so that's plus 0.43 exponent 5 tapos so that's alpha x raised to the power of 3, diba? Kasi diba t to the negative 3 pa. Okay, tapos input natin yung limits of integration. We have from 900 to 700. Okay? We should get negative 2.88. So negative 2.28, I should say. So that's negative 2.28. And this is what we predicted earlier. No? Sabi natin na dahil bumaba yung temperature, makes sense dapat na negative yung value na. We have delta S of steel. Okay na tayo dyan. Now let's get the delta S of the surroundings, which is actually the delta S of the reservoir. Okay? So the delta S of the reservoir, sabi natin is maintained at the temperature 700 Kelvin. So if you think about it, dito sa itong part na to, so if we think about this, no, yung meron kang heat na lumalabas from the from the steel as it is being cooled down. Tama? Therefore, si reservoir mo is absorbing that heat. Tama? So you can actually just say QP over T. Tama, no? But QP is equal to integral of CP dt. So this is divided by T. And again, itong integral of CP dt is QP, no? So nasa labas si T dito. So this means that magiging ganito siya. CP dt 1 over T. Okay? So let's evaluate this, no? So you see the difference, no? Ito, para nag-solve lang ako ng enthalpy. Then divide it afterwards. Pero dito, sa part na to, sa steel, nag-solve ako ng infinitesimal changes in entropy. Okay? So, dito, let's solve for this. This is 1 over 700. No? Kasi sabi, maintain that 700 siya. Multiplied by yung integral from it's QP of the steel, no? That is, kumbaga kung ano yung nire-release ng steel. So that's like saying 700 to 900. Parang ganyan. Actually, negative QP of UFE. Okay? So that's 700 to 900 because if I were to do it more accurately, dapat kasi ito, kung ganyan, 1 over T times negative. So, dapat negative na 900 to 700 because that's what happens to the steel. No? Whatever is being released by the steel is absorbed by the reservoir, which means that it should be a negative value kasi opposite sign siya. Tama? Pero if you have this negative right here, that's also like saying, pagka meron ka kasing from X to Y of something 80, pag binaliktad mo siya, magiging negative lang ng Y to X. Equal lang yun sila. Okay? So pwede natin baliktad, no? Para hindi na tayo mag-deal with negatives. Kasi usually pag may mga negative sign, minsan nakakalimutan. So ako, I just opt to reverse the limits of integration. So instead of 900 to 700, gawin natin 700 to 900 para wala na yung negative sign. Okay? So we input it all over again. No? So ito this time, pero wala nang over T. So it's 3.27 plus 2 times 3.55. 3 T minus 0 plus 10 plus 0.43 10 to the 5 tapos T to the negative 2 80. Now, actually I can use this recycle to. Pag-wave ko na lang. So, pwede ko siya i-edit. Delete ko lang to. Gawin natin over 1. So, ito, lagyan natin ng times T, times alpha X. So, if you're using a calculator, you can actually do this class. Tapos ito, instead of over X3, dapat squared lang to. Dapat squared lang siya. And let's change the limits of integration 700 to 9. Okay, so if I as equals, I should get 1823. So that's 1823 divided by 700. It should give me 1823.65. So let's divide that by 700. Gives me 2.605. Okay, or 2.61. And it's a positive value, no? And this is joules. These are all in cal per mole, no? Cal per mole because again, we have a Schumann table. If you look at Schumann's table, sabi, ito, naka-cal per mole yung mga equations. Ay, itong CP values. Cal per mole degrees Celsius. So, ito, this is cal per mole Kelvin. It's also cal per mole. Okay, so if you want to compute for the delta S of the universe, then this is just equal to, if we add the delta S um, of the steel or the system plus the delta S of the reservoir. And if we did it correctly, dapat always negative, always positive delta S ng universe, no? Because again, si wait lang. So online ba yung cycle mo? So kakalabot kasi yung cycle. Saan pwede makuha yung, okay, sige, pwede ako mag-send ng link, no, itong um, sa ano na to, no, sa software na to. Pero disclaimer lang, uh, hindi yata siya legal software. I think it's a cracked software. But siguro since third world country tayo, may konting leeway tayo in that regard kasi hindi naman natin ginagamit siya um, for for profit reasons. No? Ginagamit naman natin siya for academic reasons. May konting leeway naman tayo. So I think I can send you the link, no, or siguro yung file mismo send ko na lang. So it's just a portable na copy. Okay? Pero if you want, you can use MS Mathematics as well, no? Kasi MS Mathematics accomplishes the same thing and si MS Mathematics mas powerful pa. Pero sige, isend ko na rin just in case you are more familiar with the calculator environment. Okay? So, saan ba tayo? So, sabi natin if, di ba, ang delta S of the universe is always increasing, no? Always increasing kasi ang entropy ng universe, no, because explanation dito, the most simplest explanation here, and you can read it on the mga materials na binigay namin, is that you can imagine entropy as parang dispersal of energy, and the universe is always dispersing energy, parang kinakalat niya parati yung energy. So never mangyayari spontaneously na i-concentrate mo yung energy. So that's like saying na you can do it. So for example, if you can concentrate your energy, no? So for example, if you think about processes like, for example, yung mga metallurgical process natin, no? So we are trying to extract metal from its natural form, which is the oxide form. So in that sense, kumbaga lumalaban tayo sa entropy kasi hindi yun yung parang natural, or hindi yun yung lowest form of energy or lowest dispersal of energy na material natin. So actually, natural yung ginagawa natin, no, as metallurgical engineers. Pero the way we do it is we expend energy elsewhere, no? So kumbaga yung efforts natin of counteracting entropy is counteracted somewhere else. So that means that, and since hindi super efficient yung mga ginagawa nating processes, that means na meron talagang somewhere else in the universe that is entropy is increasing. So you can think of it that way, no? So regardless of kung may nakita kayong process, wait lang, sir, may nakita kong process na parang nag-decrease yung entropy. Ibig ba sabihin, break ko na yung rules ng laws ng thermodynamics? No, hindi siya ganun. So whether kung may nakita kayong nag-decrease yung overall entropy, it just means that somewhere else around the universe, merong nag-increase ng entropy at a greater amount. And we can see it here, no? So parang if you see dito sa itong value na to, you can see na parang dito, the entropy decreased by some amount. Pero somewhere else in the universe, which is the surroundings, nag-increase siya by a larger amount, resulting in an overall net of positive increase in the energy, in the entropy, which is, you can compute it, 2.6 minus 2.28 gives us 0.321. So 0.321. I think na nakalagay sa slides no is naka-ano siya, naka-joule siya, pero dapat calories, no? Tama? Kasi joules per, although units lang yung mali niya dun sa ano natin, it should be calories, no? Because if you look at Schumann's table, this is based on Schumann's table, no? And naka-calories naman to. Okay? So dapat, yun lang yung siguro mali dun sa handouts. We can probably correct it. But anyway, so ito siya. So you can see, ano ito? Ito siya. Ito yung overall delta S of the universe. No? And kung again, kung na-compute nyo is delta S of the universe is negative, ibig sabihin may mali kayong ginawa. So kailangan i-recheck yung solutions. Okay? So I think we can end there, no? And siguro if you notice no, yung calculations involving delta S is quite similar to sinasabi ko to earlier na sobrang kaparehas siya ng steps na tinitake natin when computing for entropy. The only difference is dinidivide natin siya by T. And the way we divide it by T is depende siya sa ano no sa pina-find sa tinatry nating hanapin. So if it's a system and it's related to i-recap ko lang no. So meron tayong tatlong delta S na type of delta S na compute. Meron tayong isang delta S na form which is associated with sensible heat. So, and it exists like this, no? Cp dt over t, wherein si t is inside of the limits of integration. Okay? Or is inside of the integral valuation. Then meron din tayong form associated with the latent heat, which is delta S is equal to just the delta H of the transformation divided by kung ano yung transformation temperature. And this can be observed by the different plane transformations. No? And if you look at itong Schumann's table, ito siya, itong mga to. So this is the temperature of transformation. Tapos yung mga delta H niya is itong difference ito. So this is a transformation. This is also a transformation. So whenever you see itong mga bars ito, that means that there is a transformation curve. And itong kung ito yung difference na to, that is the delta H of transformation. Whatever value is written here is the temperature of transformation for the particular type of transformation. Okay? So ito siya, yung latent. Tapos yung last natin is yung yung entropy that is associated with the surroundings, no? Or parang mas appropriate kung reservoir yung sasabihin. Reservoir. So kung meron kang reservoir type na parang analysis, yung delta S natin is equal to 1 over T, and sa labas siya ng 1 over T Cp dt. Because the reservoir is usually kept at a constant temperature. And in that sense, kung kinukuha mo lang kung whatever yung, this should be negative. Okay, sulat ko yung full. No? So, dapat negative QP per T or equal to negative Cp dt over T. So, take note of the difference kasi. Ito, yung over T nasa loob, ito versus ito nasa labas, yung over T. Okay? So, I think that's all for today, no? Before we end the session, meron pa tayong mga 6 minutes. Meron ba kayong questions? Meron questions here?
Sir, meron po akong tanong, sir. Wait lang, sir. Dalawa, sir. Bali una, sir, sa change in standard entropy para po sa pagkuha ng surroundings is yung T natin is always the TF, T final. Since yun yung nag-determine sa surroundings. Tama ba pagkakaintindi ko, sir, no? That is always the TF.
Sorry. Ulit, Mark.
Sa pagkuha, sir, ng entropy standard entropy for the surrounding, sir, yung T natin doon is always TF. Yun yung T final. Kasi di ba, tama ba pagkakaintindi ko? Kasi
isa lang naman yung T. So, whatever T, the reservoir is. So, for example,
kung, okay, sige, tama.
isa lang naman yung T, which is this one.
Mm. Wait lang. Tapos, sir, last sir is, di ba sir, given lang kasi dito sa problem natin na nag-positive siya since negative naman talaga ang lalabas dito sa CPDT na may integral. So, bale magpa-positive siya. If ever sir na the other way around na mangyari, so automatically i-multiply mo yung positive into negative, so negative siya. So magkakaroon ka rin ng negative na surroundings. So kung ipag-a-add mo siya to get the tawag nito, sensible heat for the universe. So bale sir, negative siya ang lalabas. Pero
Kung
bale kung mangyari yun sir, bale kukunin natin yung ano, tawag nito, yung, anong tawag yun? Yung value, yung parang may double slash na ano, nakalimutan ko yung term.
absolute value ba?
Absolute value. Tama ba ako?
Hindi siya gano'n. Never, kumbaga, never mangyayari yan. There is no
Sir,
way
'di
na
ba?
mangyayari siya.
There's no way sir na
No, hindi siya pwede mangyari.
kasi
So,
nag-negative siya sa taas sa system ng dahil sa
if ever man mangyari na, kunwari, positive to, kunwari lang nangyari is, let's just say positive value to. Mangyayari dito is, this will be a smaller value. Negative siya pero smaller value.
okay. Gets
So,
na.
kumbaga, the equations will always correct themselves, no, to follow the, ano,
Tama, mag-a-adjust siya.
call it
Tama,
that.
tama.
Basta,
Sige,
hindi siya mangyari. Kung nangyari siya na naging positive yung, or negative yung delta S mo, may mali ka sa,
pag-compute,
sa pag
calculation sa science din. Tama kayo.
So, you can do that as a sort of check, no? So, kumbaga, kung gusto mo i-check kung tama yung sagot mo, just look at the delta S of the universe. Kung negative, ibig sabihin may balik somewhere.
Salamat sir. Sige pa.
Okay. May tanong si Enzo. Sabi ni Enzo, di po ba measure of disorder po yung entropy? Bakit siya related sa enthalpy? Actually, Enzo, no? And this is discussed in one of the videos na sa module natin. The term entropy, and I can probably send another link on, and or you can search this on your own. No? Maraming articles actually that says na yung entropy or entropy being associated with disorder is sort of erroneous, no? Kasi disorder is a very vague term. Pero the way we calculate entropy, and actually entropy was calculated because we wanted a way to measure the parang yung term nila is degradation of energy, no? Because parang they noticed that yung amount of useful energy na meron sa system as you go through the process always degrades, no? Parang bumababa siya. So entropy started that way, no? Tinatry nilang i-measure through enthalpy measurements kung ano yung rate of degradation. That's why sobrang related ng entropy and enthalpy. So, yung kaya medyo problematic yung entropy as a measure of disorder is because you are trying to explain a very concise concept which is entropy using a very vague na concept which is disorder, no? And siguro I can give you an example of disorder that is vague, no? So for example, if I were to ask you, meron kang checkerboard, meron kang, let's say, chessboard, no? Tapos yung chessboard mo is in one view, kunwari chessboard mo, no? In-arrange mo in such a way na naka-layout siya at parang yung normal layout niya when starting the game. So meaning lahat ng pawns nasa harap, tapos yung rook, yun, etc. etc. So one side yung white nasa kabilang side, yung mga black pieces nasa kabilang side. Okay, so imagine that type of arrangement, no? Now imagine a second arrangement wherein ang gagawin natin is i-arrange natin yung pieces natin doon sa mga diagonal na kunwari ilalagay lang natin lahat ng pieces doon sa mga black squares. So wala tayong ilalagay sa white squares forming a sort of crisscross pattern, no? So if ganun siya, what do you think? Ano yung mas disorderly sa two cases na yun? Medyo vague, di ba? Parang hindi mo alam kasi on one hand, paano mang orderly yung isa kasi may certain pattern siyang pina-follow. Yung isa mukhang orderly kasi naka-organize according to parang white on black pieces. Okay? So that's why kumbaga si this kung if you try to uh, make it such that si entropy is a measure of disorder, medyo mahihirapan ka no kasi yun nga medyo subjective kasi yung word na disorder. So yun. So yun yung sinasabi ko. Medyo subjective yung term na disorder. And that's why medyo mahirap na kasi from the start o kahit nung elementary tayo, always ganun yung explanation ng entropy. So high school tayo, entropy is disorder. Pero it actually started because yung ganong trend was actually because we attempted to parang based on what I've ano no I've read. Nagsimula to kasi there was an attempt to make entropy a sort of household term or popular science na term. So the best way to explain it, and in some way naman accurate naman yung or medyo ano naman no, kumbaga in most cases when you try to describe entropy as disorder, medyo nagigets naman ng audience yun. Parang for someone that's first trying to learn thermodynamics, if you try to tie entropy with disorder, parang medyo magigets mo rudimentary, no? Parang ano bang term doon? Parang mas mabilis mo siyang maintindihan entropy. Pero when you now begin to try calculations and delve deeper into how entropy works, medyo lacking yung definition na disorder no, and we try to veer away from that definition. Ako kung if I were to propose a different ano no explanation of disorder, and this is in some of the textbooks I've read no, mas accurate na sabihin natin na entropy is a measure of the dispersal of energy. And you can search that on your own din. No? Try to search entropy as dispersal of energy because you have another kumbaga marami ding mga explanations why it's more appropriate. And meron ding isa entropy as in terms of probability no. So ito medyo statistical naman yung approach niya. So entropy in terms of probability medyo mas accurate din yun no. Mas nagtatay with the equations. So I'm going in a bit of a rant no, pero siguro kung bibigyan ko kayo ng reading assignment just for fun no, just try to research entropy, why entropy is not disorder. Parang ganyan. Tapos you'll find a bunch of articles that can help you understand kung bakit problematic yung disorder. Yung entropy as a measure of disorder. Anyway, meron pa ba ibang questions? Medyo go on off on a tangent ako doon. Pero that's very interesting stop ko na.